Hi, today we'll be seeing the derivations and problems for the transient analysis with AC source. So far we have seen all the transient analysis like RL transients, RC transients and RLC transients using DC source. So this is a different compared to that with respect to the source. Okay, so here we have an AC source, right? So we'll straight away jump to the derivation of RL transients. As you know, the RL transients will have a series R and an L connected to a source, but in this case it is an AC source through a switch. The AC source is named as Vm sine omega t. So Vm is the amplitude and sine omega t will give you the AC source, the frequency. Okay, so the entire derivation is similar to the DC source derivation, but the only difference is we have to apply the Laplace transform for this AC source, and from there we have to take a different path. So we'll see one by one. So let us assume the current through the circuit is I of t. So the applying KVL to the circuit will get R into I of t plus L di by dt is equal to Vm sine omega t. Okay, so this is your source value. Now taking Laplace transform, we'll get R into I of s plus L s into I of s minus I of 0 initial current is equal to Vm. The Laplace transform of sine at, so the Laplace transform of sine omega t is omega divided by s square plus omega square. Okay, so Vm into sine omega t is omega divided by s square plus omega square, or else I can, in general, if it is sine at, it is a divided by, or sine bt, it is b divided by s square plus b square. So that's what we would have seen in the initial class when I have given the formula for Laplace transform of sine and cos. Okay, so L of Laplace transform of sine bt is omega divided by s square plus b square. Similarly, in terms of in place of b we have omega, so it is Laplace transform of sine omega t is omega divided by s square plus omega square. So R into I of s plus L into s I of s minus I of 0 is equal to Vm into omega divided by s square plus omega square. Initially the current through the circuit is 0. Okay, so the initial current I of 0 is 0. So substituting it here, so we'll have R into I of s plus L into s into I of s. This will become 0 is equal to Vm omega divided by s square plus omega square. Now I will take I of s is common, so R plus s into L is equal to Vm to omega divided by s square plus omega square. Now I'll keep I of s on the left hand side, I'll take all of them to the right hand side. So Vm omega divided by s square plus omega square. So if this comes to the right hand side, it will come to the denominator R into R plus ESL. So I have to keep the coefficient of s to be 1. So I have to take L as common. So Vm into omega divided by L into s plus R by L. So this term is converted to this term into s square plus omega square. So L will go to the numerator, Vm into omega divided by L divided by s plus RL into s square plus omega square. Now we can apply partial fractions for this. So slightly it is complicated compared to the DC. Okay, so using partial fractions we'll get Vm omega by L divided by s plus RL into s square plus omega square is equal to a divided by s plus RL, because it is of power 1, so it is s plus RL, a divided by s plus RL, plus, since the second term is a quadratic equation, so we have to, power 2, we have to apply bs plus c. So you would have seen all this in the basics of partial fractions. So bs plus c divided by s square plus omega square. Let us mark this as equation 1. So we have to solve this using partial fractions. So this will become Vm into omega by L equal to, I have taken the LCM cross multiplied. So a into s square plus omega square plus bs plus c into s plus RL. So v into omega by L is equal to, multiplied inside, a square plus a omega square plus bs square plus b into RL by s plus cs plus cr by L. Just simple multiplication. Now I'll group all the s square, s and constant terms. So s square, if I common, you will get s square into a plus b. Okay, similarly the s terms, if I take it as common, so br by L plus c is equal to a omega plus a omega square plus cr by L. So these are the constant terms. Now before we equate the coefficients, I can easily solve for the value of a from this equation itself. So you can see the denominator of a contains a single power, so you can use simple partial fractions formula to solve this. So to solve this, I have to take the term under this a and then multiply with this entire term. Okay, so to solve for a, I'll take a is equal to s plus r by l, which was the term under a in the previous equation, which is equation 1, s plus r by l into the entire term on the left hand side, which is Vm into omega by l divided by s plus r into s square plus omega square at s equal to, so since we have taken the term under a, it is s plus r by l, right? So it is actually s plus r by l. Okay, we have to assume this is equal to 0. So if the r by l goes, let's say this is s equal to minus r by l. So you have to use that here. So s is equal to minus r by l at s equal to minus r by l. So these two will get cancelled, and if I substitute s in terms of s, we have minus r by l. Substitute that and then simplify it, it will become r square by l square, and then taking LCM, it will become r square plus omega square l square by l square, and all the other terms will be cancelled like this. So if the l square is like this and then l is like this, so we will get Vm, and l will go to the numerator, Vm into omega l divided by r square plus xl square. Why xl square? Because we know xl is equal to omega l. So in terms of omega square l square, I can keep xl. So xl square is omega square l square. So in terms of omega square l square, I can write xl square. So Vm into in terms of omega l, I have written xl divided by z square. Why z square? Because we know z is equal to r plus j into xl. So I can write the modulus of z to be square root of r square plus xl square, or z square to be r square plus xl square. If you square them on both sides, you will get z square is equal to r square plus xl square. Now this is what is given here. Z square is equal to r square plus l square, right? So we have got the value of a. Now we'll equate the coefficients and then find the other values b and c. So from this equation, I can equate the values of the coefficients of s square. So it will become a plus b is equal to, on the left hand side we don't have any coefficient of s square, so it is 0. A plus b is equal to 0. In terms of a, I will substitute the value that I've got, Vm into xl divided by z square. So Vm xl by z square plus b is equal to 0. So b is equal to minus Vm xl by z square. So this is the value of b. Similarly, I will equate the coefficient of s. So we'll get br by l plus c is equal to 0. So br by l plus c is equal to, there are no coefficient of s2 is equal to 0. So in terms of b, I'll substitute the value that I've got here, minus Vm xl by z square into r by l plus c is equal to 0. And I can cancel whatever that is here, because I can substitute xl with the value of omega l. I can cancel the value of l and then put all the other things to the right hand side. So finally c is equal to Vm omega r divided by z square. This is the value of c. Okay, so we have got the value of a, b and c using the partial fraction expansion, a using simple formula substitution, and b and c by equating the coefficients. Okay, now from the now substituting the value of a, b and c that we have got so far in equation 1. Now equation 1, you know what equation 1 is? This is equation 1. Okay, this is the equation that we have initially seen. This is equation 1. Now substituting all the values of a, b and c in this equation 1, we get I of s is equal to Vm xl by z square divided by s plus r by l plus minus Vm xl by z square into s plus Vm omega r by z square by s square plus omega square. You can take Vm by z square as common in all the terms. So take it out, Vm by z square multiplied by xl by s plus r by l minus xl. Okay, so Vm by z square will go out. So minus xl into s by s square plus omega square. I have split that into two terms, xls by s square plus omega square plus omega divided by s square plus omega square. Taking inverse Laplace transform. So this is the final answer for your I of s. I of s is hence here. We can take inverse Laplace transform from this. We just formula substitution. We know that Laplace transform of e power minus at is what? 1 by s plus a. So that is what the first term is, 1 by s plus r by l. So xl multiplied by e power minus at. In terms of a, we have got r by l. So minus r by l into t minus Laplace transform of cos bt is what? S divided by s square plus b square. Okay, so that is what here, s by s square plus omega square in terms of in place of b square, it is square plus b omega square. So it is xl cos omega t. In terms of b we have omega, so cos omega t plus r into Laplace transform of sin bt is what we have already seen, this omega divided by s square plus omega square. So similar to that, r into omega divided by s square plus omega square. So it is sin omega t. So we have got all the terms in the time domain. So I of t is equal to Vm by s square multiplied by xl e power minus r by l into t minus xl cos omega t plus r sin omega t. Now we cannot stop here because this is an incomplete answer. We have to write in terms of sin omega t and cos theta, in terms of omega t and theta. So I'll explain that here. So this is a general impedance triangle. Okay, so this is actually an impedance triangle where we have written the value of z using r and xl. So you can see applying your general right angle triangle rule, you can say mod z is equal to square root of r square plus xl square, right? So that is what is actually right. So z square is equal to r square plus xl square. Okay, so this is what is actually what we have seen in the previous thing also. So z equal to r plus, so z equal to r plus j into xl. From this you can write mod z is equal to square root of r square plus xl square. So z square is equal to r square plus xl square. So I can model this using a impedance triangle like this. So this actually satisfies this right angle triangle rule. So I have placed that here with an angle theta. Okay, now from the impedance triangle I can write sin theta is equal to opposite by hypotenuse. So what is opposite? So the opposite to the angle is xl divided by hypotenuse. Opposite to this right angle we have mod z. So this xl divided by mod z, opposite by hypotenuse, xl divided by mod z. Similarly adjacent cos theta is adjacent by hypotenuse, so r divided by mod z. Similarly tan theta is sin theta by cos theta, so r by mod z, xl by mod z, mod z will get cancelled, xl by r. Okay, now I of t is equal to Vm divided by z square. So it is actually mod z 1d. I can simply write as z square, or if I write z square, it actually implies that it is mod z square. If not, you can actually specify it also. So Vm divided by z square can be written as mod z multiplied by mod z, right? Mod z multiplied by mod z. So I can take one mod z inside to write in terms of these. So it is Vm divided by mod z multiplied into xl divided by mod z. One mod z will go inside, xl divided by mod z. It will be multiplied throughout, right? So for this term also and for this term also. So it is xl divided by mod z into e power minus r by l into t minus xl divided by mod z cos omega t plus r by mod z sin omega t. So Vm by mod z into xl by mod z is sin theta from this equation. So xl by mod z can be substituted as sin theta e power minus r by l into t minus xl by mod z is again sin theta into cos omega t plus r by mod z is cos theta. So cos theta sin omega t. So Vm by mod z into sin theta e power minus r by l into t plus, I'll rearrange this term to get it in the form of cos formula, which is cos of a plus b or sin of a plus b formula, depending on what we get. So it is cos theta sin omega t minus sin theta cos omega t, or I can rearrange this sin omega t cos theta minus cos omega t sin theta. I put this in the first. Similarly, I put this in the front. So minus cos omega t sin theta. This is sin a cos b cos a sin b, right? So sin a cos b cos a sin b. So a is omega t and b is theta. Sin a cos b minus cos a sin b is what? Sin of a minus b. So I of t is equal to Vm by mod z into sin theta e power minus r by lt plus sin of a minus b. A minus b is omega t minus theta. Since sin of a minus b is sin a cos b minus cos a sin b. So this is your final answer for I of t. Thank you.